Hello everybody. Today I'm just going to go through on step 3 of the solving the three-moment equation question. Previously in step 1 you have learned how to find the moment at B and C by using simultaneous equation, and then in step 2 you have also learned how to find the resultant forces at point A, B, C and D. And in this video you will learn how to draw the shear force diagram and the bending moment diagram. So these are the values that you have computed previously in step 2, where you actually find the resultant forces acting at all the points here, point A, B, C, and D. So this is just a computed values. And if you haven't watched the videos yet, you can go ahead and watch the step 2 video. But if you just want to learn how to draw the SFD and BMD diagram, you could just watch the video and learn from here. So what I personally like to do while drawing my free body diagram, SFD diagram, and BMD diagram is I like to write down all my values that I need or require under the points here. So this will help me, like at point A, I know that resultant force at point A will be 28.55, RBL will be 27.45, and so on and so forth. So this is an easy reference for me. The next thing that I like to do is to draw vertical line downwards on my graph paper from the points A, or B, C, or D, or any concentrated load or uniform load acting on the beam itself. So this will help me, just a guideline for me to draw my BMD and SFD. So if you are starting to draw your SFD diagram, and BMD diagram, you're supposed to draw an origin line. So like this example here, in order for me to draw my SFD, I draw a straight line horizontally to mark out that that's my origin for my SFD. So yeah, so we can start by drawing the at point A. So if you can see here, the point A starts at 28.55 kilonewtons, and your line should be something like that. And why is it diagonally downwards is because at point A to the next point here is actually a uniform load. So if it's a uniform load, your line should be diagonally downwards because the force is acting downwards and it is uniform throughout the beam. So it should be diagonally downwards to the next point of 16.55. So if you are wondering how I get 16.55, it's just that 4 times 3 kilonewton meter here give you 12. So there's a force of 12 newton here. So what you need to do is that just take 28.55 minus by 12 and you get 16.55. So this is the force that acts up to this point here. So this point here, there's a concentrated load of 20 kilonewton. So if you are drawing a SFD where there's a concentrated load, you are supposed to just draw a vertical line downwards to the next point. So in this case, it's the next point is at negative 3.45. So how I get that is just basically by subtracting 20 kilonewton from 16.55 kilonewton. So 16.55 minus 20, you get negative 3.45. And over here is a uniform load again. So you take 8 times 3, you get 24. So since it's acting downwards, so you take negative 3.45 minus 24 kilonewton, and you will get the next point to be at negative 27.45. So your answer here and here should be the same, negative 27.45. And since there's a force acting at B, upwards force acting at B, your line should just go back up to the next point here at 8.17 kilonewton, and that's where the start of your force is at point B. So the next point falls at 14 kilonewton. However, between point B to this point here, there's no load or any loads acting on the beam itself. So it's just a horizontal line till the next point. So like I said just now, if there's a concentrated load, just draw a line vertically downwards to the next point of 5.83 kilonewton. So your line, your the next few SFD drawings will be similar to each other. So this is how your SFD will look like, and at the end of the day, your SFD should end up at the zero mark here. So this is how your SFD would look like. The next step is to actually find the area under the curve. This is to draw your BMD diagram. So at this part here, you are supposed to find the area of rectangle, and so on and so forth. So I've actually calculated the area under the curve to be here highlighted in yellow. So you can actually pause the video as you calculate the area under the curve. Please note that you are supposed to include the calculations in your graph paper as well. So moving on, this is how you will draw your BMD diagram. So from the area that you have calculated under the from the SFD diagram, you can draw your BMD diagram. So we will start with span AB. If you notice from your free body diagram, your span AB is a uniform load. So your BMD drawing should be a curve something like this, with a maximum point here, and the maximum point will be 90.2. So here, this point here will be your maximum point, and the next point here, this point would be 90.2 minus 123.6, which will give you negative 33.4. So if you have any uniform load, your BMD should look something like this. And the next point is at 40.85. This is a positive 40.85 because it is above this origin line. If it's below, it's negative. So it's positive 40.85. So you take negative 33.4 plus 40.85 and you get 7.45. Then the next point is negative 17.45. Like I said, below the origin it is minus, so 7.45 minus 17.45 will give you answer of negative 10.04. And similarly to this one, the next point here is positive 19.85, so you will get the next point to be at 9.76. And then over here you will get your answer to be 9.76 minus 9.8, which will give you approximately endpoint at zero mark. So your BMD diagram should always end at the zero mark. If not, then your answer is actually wrong. So that's one way for you to check your answers during examinations or tests or your other tutorial questions. So that's it for this part of the video. This is how you draw your SFD and BMD diagram. Let's just go through on some of the important points for you to solve a three-moment equation question. So the first step is to calculate your MB and MC. If you forget how to do it or you need help, you can watch the step 1 video. The second step is to calculate your resultant force, which you can watch the step 2 video to learn how to calculate the resultant forces. And then in this video, you actually have learned how to draw your SFD and your BMD diagram. So just an overview, you are supposed to use your resultant forces from the step 2 to draw your SFD, and then you have to find the area under the curve of your SFD diagram, and then you can draw your BMD diagram. So these are some of the formulas that you need to know while you calculate your three-moment equation.